lesson, AP Calculus BC course. In this lesson, we will be studying 3 different topics, which is parametric curves, slopes, and tangents. We will be looking at some of the parametric graphs that we can draw, and obviously analyze the slopes and tangents of that function, as well as calculating arc lengths and displacements, right, in parametric form, looking at parametric equations and how to find the arc length and displacement, and then finally the vector value function. So now let us look at what is a parametric equation or parametric curve. Parametric curves, right? Now, parametric curves are basically defined by these functions: x of t, right? And we have y of t. Y is a function in t. For some t as a parameter, we see t is an element of real numbers. Now, sometimes it's difficult to, sketch graphs. That's the reason why we use parameters. So sometimes just say if this is a path, just say if a particle moves in this direction, right? Now, how can we find the equation of this? Right, so that's why we use parametric curves. So we say, okay, now it's moving in this direction. Look at the direction, right? So it basically started off here and it ended off there. So in part 2, we can calculate the actual distance traveled, right? The actual arc length of the particle, right? Just say if the ant moves in this pattern and it started off here and it ends off there. Obviously, the displacement will be from here to there. Now, when we are doing calculus on parametric curves, this is a parametric curve. Are we good? This is a parametric curve. So what we are required to find is some important stuff. Example, what is dy dt? Right? dy dt, sorry, not dy dt. What is dy dx? I want to find the derivative with respect to x, dy dx. dy dx is basically equals to dy dt divided by dx dt. Sometimes you can write it as y dot, dot means derivative with respect to time, over x dot, okay? It means derivative with respect to time. Okay, so we don't need to use this notation, it's fine. You can write x prime, y prime t over, you can also write this as y prime t over x prime t. Are we good? Makes sense?
Yeah, good. Yeah, makes sense.
Now, what is the second derivative? This is the first derivative. What's the second derivative? D squared y over dx squared. If you're finding the second derivative, you need to do d dt, right, of dy dx. Okay, over dx dt. So basically, I'm finding the second derivative of this function. If you cancel out the dt's, you see you get d squared y over dx squared, okay? So this is basically the second derivative. Right, now, what does, from this dy dt and dx dt, what is dy dt and dx dt? If dy, we get, if dy dt, what does dy dt and dx dt gives us, right? So we get horizontal tangents if dy dt is equal to 0. Okay? We get horizontal tangents when dy dt is equal to 0 and making sure that dx dt is not 0. Okay? So dy dt is 0. Where will we get horizontal tangents? Maybe you are looking at this flow here and you find some horizontal tangent here. Can you see? This is a point where dy dt is actually equal to 0. Okay? Then you get something called a vertical tangent. You get vertical tangents if dx dt is equal to 0 and dy dt must not be 0. Okay? Because if both of them are 0, you will not get a tangent. You'll get conflicting scenarios here. Okay? So dy dt must be non-zero. So vertical tangents is probably here. Can you see? This point here. Okay? There's a vertical tangent. And maybe you can find another point here. You can get multiple vertical tangents. Okay? Vertical tangents to curves, right? So this is a point, and that's the point where dx dt is equal to 0. Okay? Right. So those are vertical tangents. This is a horizontal tangent. And so it's quite simple. Now, before we start with calculus on parametric curves, these are calculus, all right? We need to know how to sketch a parametric curve, basic stuff. Right, so let me not take this example. Let me just give you my own example first. Let's take a linear function, right? And convert it into a parametric form, right? So we have, for example, right? If you take one linear function here, consider a linear function. Assume you consider a linear function, example, y is equal to 2x minus 4, for example. Right, y is equal to 2x minus 4, and you get something like this. The x-intercept will be 2, the y-intercept will be minus 4. Are we good? It's easy to sketch. That's minus 4, and there's 2. Now, obviously, these are set functions that you already know, right? But we can convert this into a more generalized function, which is basically a parametric equation. So how can I convert this into a parametric equation? First, I need to set a parameter. Let's call x of t equals to t. Let's call x of t, right, is equal to t, right? So x is a function in t, and then y of t, I will call that 2t minus 4, because x is t, right? Where t is an element of real numbers, where t is from minus infinity to infinity. Are we good? So I have just generalized this using parametric equation. So I converted a linear function into a parametric equation. Does that make sense?
Yeah, makes sense, sir.
Right, so it's easy. Now, how do we get these coordinates now? It's easy to get these coordinates. Let's make t 0. If t is 0, see this point here. If t is 0, then 2t minus 4, 2 times 0 minus 4, you can see this point occurs there. So this point is when t is equal to 0. What about 2? You'll get 2 when t is 2, okay? If t
Get
is
0.
2, yeah. So when t is 2, you get y value 0 and you get x value 2. That's it, yeah. So you can see this, but now in parametric equation, you have something called, and you use an arrow to show the movement, and you always start from lower t value to higher t value. You can see the graph is moving upwards like this. Can you see? Because 0, 2, you need to show the direction. Okay. Just say if this is some particle and moved from, or just say if this is an ant, it moved from here to there, then you need to show the direction. Are we good? Now,
Very good, so okay.
let's look at this example here. Let's sketch this parametric curve. All right, I want to sketch this parametric curve. So sketch and identify the curve defined by the parametric equation. The set must identify as well. So it's possible that it can be written in, it's possible that it can be also written in a Cartesian form, right? This is a parametric form, that's a Cartesian form, okay? So Cartesian means X and Y. Now let's see. I'm going to choose some T values, right? Then I will get X coordinates and then I will get Y coordinates. And let me start my T value maybe from -3 to 3, right? I'll start from -3, then -2, then -1, 0, 1, 2, 3. Right? I don't usually take so many points. I just usually go from -2 to 2. Anyways, let's check. If the value of T is -3 plus 1, all right, -3 plus 1 is -2. If the value of T is -3, that's 9, correct? Plus 6, which is 15. So you have a coordinate, -2, 15. If the value of T is -2, you get -1. -1 squared is 1.
No, -2,
1.
so 4 minus 4 plus 4, it will be 8.
No, 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 no. Ah, yes, 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 yes. Yeah, yeah. This is right. This is 8. That's correct. If the value is -1, it will be 0 here. If it's -1 here, if it's -1 here, it's going to be 3, correct?
Yeah.
If the value is 0, then it's 1, and that's 0. If the value is 1, it is 2, and 2 squared is 4. You get 0. If the value is 1, no, 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 that's incorrect. Substituting 1 inside here, 1 squared is 1. 1 minus 2
-1,
is
yeah.
-1, yeah. If the value is 2, that is going to give me 3, and that's going to give me 2 squared, which is 4. 4 minus 4 is 0, correct? If the value is 3, then that will be 4. 3 squared is 9. 9 minus 6 is 3. So these are the coordinates that you need to sketch, okay? Now I'm just looking at the x-axis. X-axis is giving me, so the y value is going very high, -15. I will not take that, right? So I'm not going to take -3 as my coordinate. I'll leave this out. I'll take the rest. 8, 3, 0, -1, 0, and 3. Okay, those are some good points. And these points are, so even this point here, I wouldn't really take it because remember, it's way too high up. So kind of like need to do that. Okay, it's fine. We can go 8 up, no issues. Let's see. So you got 1, 2, 3, 2, 4, 6. Let me just say 8 is there. I'm gonna take 1 here, 2 there, 3 here, and 4 there, right? -1, -2, -3. I don't think I need -3 as well. All right, so now let's sketch this function and see what we are getting. -2 and 15, we're not taking that one, we said. We're taking -1 and 8. -1 and 8, we will take that, right? We will take, remember to put arrows, right? 0 and 3. 0 and 3 is right here, okay? Then 1 and 0. 1 and 0 is right here. And then 2 and -1 is right here. And then we got 3 and 0, so right here, okay? And then you got 4 and 3, 4 and 3, okay? You can see the graph. Let me join this part of the graph. You can see this graph is like almost a quadratic function. Can you see? And my arrow is moving downwards, okay? Because I started off at -2. This value is when t is equal to -2. This here happens, we get 3 here, 0 and 3 when t is -1. And when t is equal to 0, you're getting 1 and 0, correct? And this point, you are getting when the value of t is, yeah, you're getting a horizontal tangent here, correct? Which is 2 and -1 when the value of t is equal to 1. Are we good? Make
Yeah.
sense?
Yeah.
Right. I want to check if this horizontal tangent is actually true. So when do we get a horizontal tangent? When dy dt, when dy dt, we're finding dy dt, we need to set that equal to 0, right? When the horizontal tangent is when dy dt is 0. So let's say if dy dt 2t minus 2 is equal to 0. So t is equal to 1. Perfect. At t is equal to 1, there's a horizontal tangent. And make sure that dx dt is not dx dt. What's dx dt? 1. You can clearly see that's not 0. So the horizontal tangent is at t equals 1, which is great. This is t equals 2 and this is t equals 3. So this is your parametric curve. Are we good? But now, can I take a parametric equation and make it into a Cartesian? Of course you can. If possible, you can, because if you can convert a parametric equation into a Cartesian equation, known Cartesian equations that you know, which is much better because now you only got to deal with 2 variables. But in this case, you are dealing with 3 variables, t, x, and y. You see? So if you can convert this into x and y into a single equation, it is better. So let's check if you can do that. Remember, they're saying that the value of t is x minus 1, is it? Look at this. I'm converting the parametric equation into Cartesian form. So I've got x equals t plus 1 and y is equal to t squared minus 2t. I will not change y. I will keep y is equal to t squared minus 2t. All right. Now, what is t? I can eliminate t. T is x minus 1. T is x minus 1 from the first equation. I took the 1 over to the other side, minus 2 into x minus 1. Now, obviously, you can simplify this entire equation and make sure that this here actually works. So this is x squared minus 2x plus 1 minus 2x plus 2. So your equation is x squared minus 4x plus 3. You can see the y-intercept is 3 and it's a quadratic function, okay? You can check all your minus b over 2a and all this and check your turning points and you can check your vertex and everything. So I just converted. So now I can completely forget about this equation and deal with this equation. But now, the reason why we study parametric curves and parametric equation is because not always you can find an explicit equation. This is an explicit form. Why? Why is this an explicit form? Because for each x value, you get a y value. Okay. But now over here, for each t value, you're getting x and y value. You see the difference? Are we good?
Yeah, I see. Yeah.
Right, excellent. Let's move on to the next part. Now we're going to do some calculus on this parametric curve here. So question number 1 is sketch the parametric curve. So let's sketch the parametric curve. See, the curve is quite complicated. Is x is equal to t cubed minus 3t. So I'll draw my table on this side, right? I choose some t values, some x values, and some y values. Now the question is, can I do this on the calculator? Of course you can do this on the calculator, right? And how can you do this on the calculator? You can just call it f of x, g of x, starting value, ending value, right? So let me just do that. So I would actually do it like this. So I'll just say table method 7, f of x, I'll just say x cubed minus 3x, right? And g of x, I'll say t squared minus 4, right? And I will start at -2 and at 2, right? Just for simplicity. Right, so t values, I'm taking -2, -1, 0, 1, and 2. So let me see. Remember, that's what I put in. So -2, 2. Okay, let's say -2, 0. I've got 2 and -3. 0 and -4. -2 and -3. 2 and 0. Okay. Now let's check if these points actually work. Let's substitute -2 here. -2 cubed is -8. -3 times -2 is 6. So -2. Substitute -2 here. Then we get 0. So it works. Okay. Are we good? You can see it works. So let's sketch this parametric curve. Okay, so these coordinates are not so bad. It's moving. It's quite simple. So we're going like -4 down and nothing up. -4 down. And we have -2. Okay. So let's see. That's -1. That's -2. Okay, we didn't take. Yeah. -2 to 2. X values, Y values 0 to. So 0 here is -1, -2, -3, and -4, right? So when the x value is -2, 0, -2, and 0 is on the x-axis, right? Then we have 2 and -3, 2 and -3, right? 2 and -3, right? 2 and -3. Then we have 0 and -4. 0 and -4. Then we have -2 and -3. Then we got 2 and 0. Hmm. Problem here is, what kind of curve is that? So is it like you're going to join up here, right? And then 2 and -3, and then you have 0 and -4, and then you had -2 and 3, -3, and then you had 2 and 0. Can you see? But now obviously it's a curve. It's not actually, because remember, you just took integer values, okay? If you took more different values, what about the value of 0? 0 gave us -4. Ah, okay. So I can see it's basically you need to take some points in between as well. All right. You can see how this curve is going. It's like this. Can you see? It's a curve like that. But we have to take values in between to get a more accurate curve. Okay. So I'm going to put here, my starting point was here, right? So this is t equals -2. Then we have t equals -1, so I don't forget. And then we had t equals 0, third point. Then we have t equals 1, fourth point. And fifth point is when t is equal to 2. We need more points, all right? We need points in between. Makes sense? So if you try to take points in between, like what points in between we need to take? You know what points we need to take? 1.5, 2.5, things like that, okay? So I'm not really gonna waste time doing that. What I'm going to do is I'm just going to draw the curve, but does it intersect through -1? That's what I need to know. At 0, it is -4. Is there 2 points of intersection? How many y-intercepts are there? If you make y equals 0, and t is equal to, no. Where else is it intersecting? Okay, what I will do is I'll just draw a rough curve. Okay, I just drew a rough curve. Are we good? Makes sense. You'll get
Yeah,
a curve
makes
like
sense.
this, basically. You need to substitute other points, like take a point between -2 and -1, like -1.5. You need to put it into your calculator and check what's -1.5, then what's -0.5, because you can't draw straight lines in there. It's a curve. You need to take 0.5 and you need to take 1.5. I don't want to get too much into detail. What's important here is I want to do the calculus on this curve, all right? I want to do calculus on this curve. Now, obviously, this here continues. What's important is the arrows. How does the arrow move? It needs to go in this direction, come down, moving in that direction, continues there to there. Okay? Now, obviously, this curve can move on. Curve can move on. All right, so there's your direction. You see, it went like this loop, went in this direction, down, up, up. How we know that? We need to move with time t, parameter t. Now let's find find dy dt, find dy dx in terms of t. Now we want to find the derivative. Right. Now you are doing calculus. Part B. So what's the calculus on this? You are finding what is dy dx. Dy dx is dy dt over dx dt. You can see dt's cancel out, so you still get dy dx. So now what's dy dt? Find the derivative of this, which is just 2t over, what's the derivative of this? 3t squared minus 3. Make sense?
Yep.
That's it. That's your answer. Okay. Part C. Find all points where the curve has a horizontal tangent. Where is the curve horizontal tangent? It is horizontally tangent at t equals 0, isn't it? And the coordinate is 0 and -4. We can see it visually from the graph. It's a horizontal tangent here. Right here, there's a horizontal tangent. Right over here, we can see a horizontal tangent and we can see vertical tangents here. Okay. So let's check if that actually works. So for horizontal tangents, we need to say dy dt is equal to 0. Horizontal tangents when dy dt is equal to what is dy dt? We just found dy dt, which is 2t is equal to 0. So when t is equal to 0 and we need to check dx dt. Dx dt evaluated at 0. Make sure when it's evaluated at 0, it is not 0. So dx dt is 3t squared minus 3. So dx dt is 3t squared minus 3. Evaluating this function at 0, evaluating it at t equals 0, not x equals 0, at t equals 0, you are getting negative 3, okay? And you can clearly see negative 3 is not equal to 0, okay? So you only have a single horizontal tangent, and the horizontal tangent is when it is at t equals 0. Now, if you put t equals 0 in x and y, you should get 0 and negative 4. So where's the horizontal tangent? At 0 and negative 4. X and y coordinates, okay? Next one.
Teacher, here one question. Sorry,
Yes,
before
what's
you
your
go on.
question?
We see from the graph visually that the t equals to 0 is our horizontal
Correct.
tangent, yeah, visually.
Yes, yes.
But for
Visually.
proving, we need this one here.
Yeah.
But if, for example,
Yeah, if they tell you not to draw the graph and they go straight into this question here, if they go straight into part B and you skipped part A, they didn't tell you to sketch a graph, then what would you do? You will not sketch a graph. You'll do the calculus on it. Okay?
yeah, that's why I'm saying we need
Yeah.
this case formula for proving. Yeah. Okay. Okay.
Yes. Yes. Let's look at D. Find all points where the curve has a vertical tangent. Vertical tangents is when dx dt is equal to 0, right? Vertical tangent is when dx dt is equal to, what is dx dt? It is 3t squared minus 3. When that is equal to 0. If you solve this, you get t is equal to negative 1 or t is equal to positive 1. And if you substitute either of these values in dy dt, evaluated at t equals plus or minus 1, you can clearly see that's not 0. Why? Because dy dt is 2t, isn't? Dy dt is basically equals to 2t. And if you're evaluating 2t at plus or minus 1, if you're evaluating 2t at plus or minus 1, you'll get two different answers. You get positive 2 and negative 2, and none of them are 0, isn't? So that's basically non-zero. You have to check the second case as well. Right, so at t equals negative 1 or t equals 1, I have vertical tangents. So what are the coordinates at t equals negative 1? When t is equal to negative 1, my x and y coordinates are at negative 1, minus 2, and minus 3. And when t is equal to 1, my x and y coordinates are 2 and negative 3. Are we good? Does that make sense?
Yeah, it makes sense. Sorry.
Yeah, you can see that's why I sketched the graph for you first. I didn't go straight into calculus. So you can clearly see, you can verify from the graph that it actually works.
So I have one question. Sorry, for the
Yes.
vertical tangent, we say that for vertical tangent, the dx over dt it should be must equal to 0, and the dy over dt not should be equal to 0. Yeah.
Yeah, it should not be equal to 0 evaluated at that point.
Yeah. Okay. So if, for example, our dy over dt will be dt minus 2, it means that in positive one it will be incorrect because 2t minus 2 will be 0. So it means that if the positive one is giving us 0, but the negative one not giving us 0, in that case it means that it's also incorrectly, yeah, because one of the
Wait, wait, wait,
intercepts
wait.
giving us that.
Okay, let's evaluate the dy dt. If you evaluate dy dt, if you substitute positive 1, you get negative 2. That is not 0. And if you substitute 1, you get, if you substitute negative 1, you get 2 times negative 1, which is negative 2. If you substitute positive 1, you get 2. And that's also not 0.
No, I mean in the other case, in other example, for example, it will be like 2t minus 2, for example, I saying. In the
Ah,
positive one,
yes,
it
yes,
will
yes.
be. See, I mean this one. The positive side giving us the incorrect, the negative correct. It means that in this point there is no vertical tangent. Yeah,
In this
in
case.
that case. Yeah. If for example one of the signs giving us incorrect answer.
No, you have to get not equal to 0.
Yeah, not equals to zero, of course. Yeah, I mean
Yeah,
like this.
the second case has to be not equal to 0. The first case you can get
Mm,
anything, but the second case has to be evaluated at these T points.
okay, okay.
You have to check evaluation at this point here. Because if it does equal to 0, then you have a problem. Then you can't say it is a tangent. It's some other, maybe it's a saddle point.
Yeah, that's why it's asking. Yeah. Okay, okay. Thank you.
Hmm, good. Now, next one, we want to find what is the second derivative. Now, remember, we found the first derivative. So we're going to continue the example from there. So that's basically d dt of dy dx, right, over dx dt. Now, let me just check what was y of t. What was dy dt, okay? Dy dt was basically 2t, if you remember from before. Dy dt is 2t, and dx dt is 3t squared minus 3. Okay, now we can just do all of this one time. So to find this derivative, we're going to do d dt of what's dy dt, dy dx, 2t. Yeah, what was dy dx? Dy dx was 2t over 3t squared. And what is dx dt? Dx dt we already have. I'm just going to factor this out. Dx dt is 3 into t squared minus 1. I'm just substituting into this formula. Now, to find the top, you got to do quotient rule, okay? Because it's a function in t, you're differentiating. Okay, so let's apply quotient rule here. Derivative of the top is 2, leave the bottom. If you leave the bottom, let's leave it in factored form. 3 into t squared minus 1. Subtract, differentiate the bottom. I'll differentiate the expanded form. You understand this? Differentiate the top, leave the bottom. Differentiate the bottom, leave the top. Quotient rule. 6t, and leaving the top, you get 2t, right? And is divided by the denominator squared. So if I square the denominator, I'm going to get 3 squared. When you're squaring the denominator, you're basically squaring this. So 3 squared is 9 into t squared minus 1. And now this part is still divided by all of this. So dividing by this means multiplying it by this part here is divided by 3 into, so multiplying it by 1 over 3 into t squared minus 1. And that's our answer. We're still going to simplify this, okay? Remember, there's a square there. You're squaring the denominator. 3 squared is 9. T squared minus 1 squared is this. So let's simplify the top. I've got 6t squared minus 6 minus 12t squared. Okay? Divided by 9 times 3 is basically 27 into t squared minus 1 all t cubed. Okay? Let's see if we can factor the top. The top is giving me minus 6t squared minus 6. So that's not going to help us. So all we can do is just take out a negative 6. Left with t squared plus 1 over 27 into t squared minus 1 all cubed. Does it make sense?
Yeah, makes sense, sir.
And then the minus 6 and the 27, you can simplify that, okay? Isn't you can simplify that?
Yeah, 3 and 9, it will be like 2/9. It will be like negative 2/9, like this, yeah.
Yeah, 2 and 9, yes, correct. So my final answer for d squared y over dx squared is minus 2 t squared plus 1 over 9 into t squared minus 1 all cubed. All right, that's it. And why do we need the second derivative? Because if this is some particle, right? If this is some particle, we need to find the acceleration of the particle at some point. Okay? That's why we need the double derivative. Okay? If I ask you what's the acceleration of the particle at a certain point, then you can substitute inside here and solve it. Are we good? Substitute inside this double derivative equation. Now, next part. Right, so this is basically calculus on parametric curves, finding the single derivative, double derivative. And now what we move on to the next part, which is called arc length and displacement in parametric form. Easy section, all right? It's just that the integrals are, you need to know the techniques of integration to solve this. And so what are arc lengths? So if you remember the diagram from before, okay, let me draw a new diagram. Arc length, another word for arc length is actual distance, right? Arc length, which is distance, and is given by the formula L is equal to the length. And what is a curve? You can get a curve like that, right? Right, so it started off at this point here, right? T equals A, and it ended off at that point, which is T equals B, right? So the arc length is the integral from A to B of, remember the function is x of t and y of t, x of t and y of t. Those are functions, parametric functions. So you're going to say x prime, so dx dt squared, the derivative squared plus dy dt squared dt. Are we good? This is the arc length. And what is the distance? What is the displacement? Displacement is easy, it's just a straight line distance from starting point to ending point, okay? This is the
Yeah,
displacement. Displacement is always straight line. Distance is a problem, okay? And so started displacement is just basically a straight line. Right, so displacement, we say the square root of, right? So you need to get the initial coordinate here, right? At t equals a, you need to get the coordinate x1, y1, and t equals b, you need to get the coordinates x2, y2. Are we good? And then you just use displacement formula, which is x2 minus x1 squared plus y2 minus y1 squared. Are we good? That's it. It's just basically the distance formula. Actually, the displacement formula. In this case, displacement is always from starting to ending point. Right, so let's have a look at this example and solve that. Right, so this is part 2, more calculus on parametric curves. Right, now I'm not asking you to sketch this curve because it's quite difficult, because look at the type of curve it is. 2t plus 1 and ln t. Might not be difficult, it's basically just a ln function, and it's a shifted ln function. Because the value for t is actually x minus 1 divided by 2. So it's possible to sketch this function, but I'm not going to sketch it, right? Find the distance traveled by the particle, arc length. In other words, let's find the arc length of this. So first what we're going to do is arc length is basically dx dt, right, squared plus dy dt squared. So what is dx dt? If you're finding the derivative with respect to t of this function here, what's the derivative of this? 2. Easy, right? That's just 2 squared plus, what's the derivative of ln t? 1 over t, right? Don't forget the integral. That's just the integrand. The integral is from a to b. What is a to b? From 1 to e. Okay? Don't forget the square there. Right, we need to simplify this inside. So that's from 1 to e of 4 plus 1 over t squared dt. Make sure the integral is not improper. So we can say t is not 0. T can't be 0. So which is great. It's from 1 to e. So integral is not improper. And this part is always positive. So we got from 1 to e. See how I'm going to simplify this. You take a LCD inside. You're going to get 4t squared plus 1 over t squared. Makes sense. So if you split it up, you get 4 plus 1 over t squared, square rooted. Is that good so far? Just basic algebra.
Yes, sir. Basic
Right,
algebra.
now watch. Next one, integral 1 to e. See this 4t squared plus 1 over t squared? That is 2t, that's squared plus 1 over the square root of t squared is just t. Okay? You can put absolute value of t, but now remember the absolute value will fall out because it's from 1 to e. 1 is positive, e is positive. That's the reason why the absolute value falls out. Now watch. Why did I put it in this form? Because it's one of your square root forms, isn't? So you say let u equal to 2t. Is it? Let u equal to 2t. So du is equal to 2 dt. If t is 1, then that's 2, and that's 2e. I change the boundaries. What is dt? Du over 2. And that is basically u squared plus 1. And what is t? U over 2. So u over 2, this 2, and that 2 can cancel out, right? Because if that become 2 over u, yeah, that those 2 will cancel out. And now you're basically evaluating this integral here. It's one of the square root forms, okay? And which square root form is it? It's the square root form with a tan theta. So you say let u equal to tan theta. How you know that? If you go back to your notes, right, with this techniques of integration. Because those square root forms, yeah, that's here. See a squared plus x squared, okay? A tan theta. the value of A here is basically 1, I think. Yeah, the value of A here is actually 1. Okay. So now you find du is sec squared theta d theta. Draw a triangle to check if you're on the right track. U over 1. So this is square root of u squared plus 1. We are on the right track. Okay. Make sense? Now, the integral here transforms. That is the arc length integral, all right? That transforms into, should we change this, 2 and 2e? If the value of u is 2, then theta will be tan inverse 2. And this will become tan inverse 2e. Well, those are just answers. Those are just values, right? So that's why I just put it there. It's fine. Now, still have a problem here. Tan theta, u is tan theta. Yes, what is the square root of u squared plus 1 over u? If you're looking at this, what's the square root of u squared plus 1 over u? Square root of u squared plus 1 over u, you can clearly see it's already in the triangle. So what is this entire part here? Look at this entire part of this. Look at what you have in the integrand. What is this part? U squared plus 1 over u is basically just cosec theta. Isn't? Not opposite of a hypotenuse, but this is hypotenuse over opposite. That's what you have here. And what is du? Du is sec squared theta d theta. And also remember the identity, tan squared theta plus 1 is equal to sec squared theta, because this will help us. Now, how do we evaluate this integral, right? You can't really evaluate this integral. In order to evaluate this integral, you're going to use this identity and convert it. Let me just call it theta 1, theta 2. That's what it is. Cosec theta into, what is sec squared theta? Tan squared theta plus 1, right? We can multiply these two out. And tan squared, yeah, tan squared theta. You with me?
Yeah.
And split this up. Cosec theta. Now this is a problem because remember there was two parts to the integral. This is one part and that's the second part. So I just split it up into different integrals, right? Because remember, integral of a plus b dx is the same thing as saying integral of a dx plus integral of b dx. Is sum of integrals. You can take it into different parts. This one we can evaluate by changing this into sine and cos. Cosec is 1 over sine theta. And this is sine squared theta over cosine squared theta d theta. Okay. Plus over here we got to use a trick because evaluating a single, right? It's not a pair. The integral of cosec squared theta is negative cot. But now this is not cosec squared. Right, this is cosec. So you got to use a trick, cosec theta times cosec theta cot theta over cosec theta plus cot theta. It's like a trick that you're going to use. So it's like multiplying by 1 over 1 d theta. Over here for the red part, That does simplify theta 1, theta 2. That's just basically sine theta over the sine and one sine cancel out over cosine squared theta d theta. You can make this here equal to u and solve, but over here, what's the problem? You need to make this entire thing, bottom part, equal to u, right? Yeah, so let's leave it like this. And now let's try u substitution here now. So over here, I'm going to say let u equal to what? Cosec theta plus cot theta. So what is du? Du is, what's the derivative of cosec? Cosec cot, is it? Negative cosec theta cot theta. And what's the derivative of cot? Negative cosec squared theta d theta. Are we good? And over here, what u substitution you use here? You say let u equal to cos theta. So du is equal to negative sine theta d theta. Okay? Make sense?
Yeah, makes sense, sir.
All right, let's solve this one now. This is easy. Now remember, I'm changing it back to u, so I'm just going to keep the integral like this. I'm going to call it u1, u2, right? Because I'm going to change it back to u here now. So what is sine theta d theta? That's negative du, negative du. And what is this? 1 over u squared. 1 over u squared is the same thing as saying u to the power negative 2. Make sense? So this is power rule. Easy to integrate this. But what about this now? Plus, what about the second integral here? So I'm going to call it u1, u2. Let's call it u3 and u4. No, it's still u3, u4 because different values here. Yes, what is u? Cosec theta, cot theta. So the denominator is u, okay. What is d theta? Do we have, oh yes, we can evaluate, we can simplify du. Du over here, I can take a negative cosec theta as a common factor. I'm left with cot theta plus cosec theta d theta. So great, we got cosec cot, isn't? We do have cosec cot and d theta, so that's also negative du. Great, that's also negative du. That's it. That's negative du over u. So this part ends up being len, right? This part ends up being negative len u and no plus c, all right? And this part here ends up being u to the power negative 1 over negative 1. And remember, there's a negative outside there, and that's u1, u2, minus negative len u, u3, u4. Now, I'm ready to substitute everything, and we have an answer. Right, so what is this? Negative, negative cancel out. This is 1 over u, right? But the question is, what was u? U was
Cosine, yeah.
cosine theta, right? Right? And didn't we have theta values? What was the values, upper and lower boundaries? It was tan inverse 2 and tan inverse 2e. Isn't that what it was?
Yeah, it
Theta
was,
1,
yeah.
theta 2. Yeah, that's what it was. Tan inverse 2, tan inverse 2e. And what is this? Negative len. What was u over here? The value of u over here was cosec theta cot theta. And same, tan inverse 2 and tan inverse 2e. Now, you substitute all this inside here and you will get an answer, okay? So this one is upper boundary minus lower boundary. So what we have is 1 over cos of shift tan 2, right? I'm substituting the upper boundary order. 2e it was. Shift E. Where's the E button? Ah, there's it here. No. Alpha E. Okay. I'm getting 5.5277. I need to subtract. My calculator in R mode, which is great. 2.236. 2.2361. Right? Subtract len, substituting that inside here, upper boundary, subtract len. You can see what a headache this is. Len cosec. What is cosec? 1 over
Sine.
1 over sine. Yes, sine tan inverse, shift tan inverse 2e, 2 alpha e, close brackets, and I'm going to close it again, plus cot is 1 over tan, isn't? Yeah, cot you can write it as 1 over tan. But then now tan, what is cot is 1 over tan, and in the place of theta, you're substituting tan inverse. So tan and tan inverse just cancel out. You're just going to get 2e in the denominator, okay? But it's fine. I'll write it out for you. Tan of shift tan inverse 2 alpha e. Are we good? So what's
Yeah.
tan of tan inverse? Tan of tan inverse just 2e. That's it. Why syntax error? Oh, I forgot to close a bracket here as well. Yeah. Right, so I've got 0.1829. Right? And subtract lower boundary, substitute 2 in there. Let's take out the e's. And let's take out the e's here. 0.4812. Okay? Upper boundary minus lower boundary. And I took the len of the whole thing.
Yeah, it's correct, sir. Yeah, then.
All right. Now I'm just going to minus everything up now. 5.5277 subtract 2.2361 subtract open bracket 0.1829 subtract 0.4812. I'm getting 3.5899. Okay. Now I want to check the original integral that I had, because what if your question is just multiple choice, and if they ask you free response question, and you can also write it in this form, you can transform the integral. This is the first form, and then it comes out to be that form there with the 4t squared plus 1 over t. So what if I just try to evaluate this, the original form here? Let me see if I get the same answer. Integral of, unless we went off somewhere, 1 to e. Square root of 4 plus 1 over alpha x squared. 3.5899. Great. Amazing. Are we good?
Yeah, great, sir. Same
Yeah.
answer. Yeah.
Same answer. Exactly. So you can see, you need to double check your answer here. Check your answer, right? And we got 3.5899. So approximately 3.59. And you see, we got this exact same answer. We went this whole long process to do something like this. Now, it's very important that I need to teach you something here. You got to remember the basic rules for this integral, especially. The integral of cosec theta d theta. You need to remember the short form, all right? And the short form is negative len cosec theta plus cot theta, right? Plus c. And another important point, integral of a single like cosec, what about sec theta, right? That is just len sec theta plus tan theta, right? Plus c, because you're integrating not a pair, you are integrating singles, right? You understand?
Yeah.
Right, right. So great. Now, this was only the first part. Find the displacement of the particle. Let me take this part bottom and then do part two. Part two is here, right? Part B. Part B would have been much more easier. Finding the displacement. Oh, what is that? That's a joke, right? What is the displacement? Where did you start off the particle? The particle started off at t equals 1. For t is equal to 1, what are the coordinates? If t is 1, the coordinate is 1, 3, isn't? 3. I'm substituting here. I'm finding the displacement, okay? 2 times 1 is 2 plus 1 is 3. And len of 1 is 0, 3, 0. And if the value of t is equal to e, right, you will have 2e plus 1, right? And what's len e? Len e is basically 1, isn't? What's len of e? 1. Are we good? So what's the displacement? Displacement is square root x2 minus x1. So 2e plus 1 minus 3 squared. So in other words, 2e plus 1 minus 3. That will give you 2e minus 2 plus 1 minus 0. So 1 minus 0 squared, right? So that's easy now. You just put this into the calculator and get an answer. Otherwise, if you're going to put it in normal form, you're going to just have 4e squared minus, what is this? 8e plus 4 plus 1 plus 5, right? So you'll have this answer here. What's the answer for that? Square root 2 alpha e minus 2 squared plus 1. I'm getting 3.5791. 3.5791. Right. Now, remember, there's no link. You can't say there's a link between that one and this one. It's just because the way the curve is structured, okay? You understand? Look at the
Yeah.
answers are very close. The answers are very close. Can you see? 3.5791. And this answer 3.5899. The answers are very close. Now, you can't go and mix up these two concepts, okay? Because remember, a displacement is starting position, ending position, just finding a linear, right? So you're just finding from starting to ending position, you're finding the arc length. That's you're not finding the arc length, sorry, you're finding the displacement. And over here, you're actually finding the arc length. It's because the way the curve is structured. Remember what I told you about the curve, that you can go and convert this curve. You can go and convert this parametric curve, into Cartesian. How? Right, so you can convert this into Cartesian like this. But then you got a problem with 1 and e, right? So if you convert this into Cartesian, I'm just showing you what the curve looks like. You're going to say y is equal to len. What is t? T is x minus 1 over 2. Dividing both sides by 2. So half x is basically x minus 1 over 2, isn't it? So you can write this as len x minus 1 subtract len 2, right? So this is a function. So basically this was a len graph and it shifted 1 unit to the right and len 2 units down. So you got a graph like this. Okay. So that's why when you're trying to find the linear distance here, right, is coming very close to the actual arc length. Can you see? That's the reason why. Is because the way the graph is sketched. Right, so you don't need to go into the details of sketching. You need to know the calculus on these parametric curves, okay? I'm just showing that the answers are close is because of the way the curve is. The curve is basically one increasing function. Right, great. Now, let's move on to the last part. The last part, you understood everything there, right?
Yeah.
The last part is vector valued function. Now, in vector valued function, what we do is we find position vector, we find the velocity vector, we find the acceleration, right? So that's what we're looking at in vector valued function. So the position vector in vector valued function is defined by what is a position vector? We have a position vector. Now, remember, a vector has magnitude and direction, right? Right, so the position vector is R of t. Wait. R is a vector. I'm just underlining it. I'm underlining the vector to show that it's a vector. R of t is x of t and y of t. You know what x and t and y of t are? Those are functions, parametric equations. From the position vector, you can get the velocity vector, right? So what's the velocity? V of t. It is basically differentiating that and differentiating that. That's basically the same thing as saying r prime t, okay? How do you
Yeah,
find
it's
r
a,
prime t? Just find x prime t and y prime t, okay?
and
That's a
to go
velocity
on
vector.
the
Yeah, now from the velocity
acceleration and
vector,
all.
yeah, acceleration, one more, good. But how can we find the speed from this? To find the speed, you're going to say absolute v of t, all right? And
Uh,
you're going to say square root this component squared plus that component squared. X prime t squared plus y prime t squared, okay? Because you're kind of finding the magnitude of this, right? Now, what's the acceleration? Acceleration is differentiating the velocity vector, right? Which is a of t, which is r double prime t, the same thing as saying v prime t, right? Which is the same thing as saying x double prime t and y double prime t, right? And acceleration is a velocity. Sorry, acceleration is a vector, so you can't really find this thing, right?
sure, and also we will stop on the acceleration because there is also
Yeah,
continuous of the acceleration because like
no,
jerk
no,
and other
no,
things.
no, no,
Okay,
no.
okay.
We did just stop at acceleration, yeah.
And so for going backwardly, we can use the integral. For example, acceleration go
Yeah,
to the
yeah,
velocity.
correct.
Okay,
That's
okay.
correct. Now, let's look at A. Find the velocity and acceleration vectors. That's easy. What's V of t? V of t, we need to look at R of t, all right? There's R of t, 3 cos 2t, 3 sine 2t. So let's find the velocity vector. Just find the derivative of this. So there's 3. Derivative of cos 2t is negative sine 2t times the derivative of the inside, which is 2. Okay? Finding the derivative of the next one is 3. Derivative of sine 2t is cos 2t. And then finding the derivative of 2t, which is 2. Right, so let's simplify this. That's minus 6 sine 2t and 6 cos 2t. Are we good? Make sense?
Yeah, makes sense,
And
sir.
you have to use these these bracket notations. This represents vectors, okay? This is vectors. This is a notation for vectors. You can't use round brackets like this. Yeah, these are basically vector notations, vector braces. Now, what's the acceleration vector? A of t. We're basically differentiating this, right? So minus 6 derivative of sine 2t is cos 2t times 2. 6 derivative of cos 2t is negative sine 2t, right? Times 2. Are we good? So the acceleration vector is minus 12 cos 2t. Both of them became negative. Yeah. And 12, negative 12 sine 2t. Are we good?
Yep.
Find the speed. See what they said? Find the speed at t equals pi by 4. First, we're going to find the velocity. Right? Let's find v of pi by 4. So if you're going to substitute pi by 4, you get negative 6. You'll get negative 6 sine 2 times pi by 4. 6 cos 2 times pi by 4.
Teacher, no, I think you should take the three, not negative, not the six, no? Oh, yeah, 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 yeah. Yeah. You just make it
This one,
shorter, yeah.
yeah,
Yeah,
yeah.
it's shorter. You make it shorter. Okay, okay.
All right, so what we're going to do now, you just use a calculator and solve. But if you know what is sine of pi by 2, sine of pi by 2 is basically 1, right? This is sine graph, and the cos graph is that. Cos pi by 2 is 0, so this part is 0, right? So this whole thing becomes 0. And what is this? Negative 6. So what's your velocity? Absolute v is square root of negative 6 squared plus 0 squared. So that is just 6. Make sense?
Yeah, makes sense. So yeah.
Yeah. So that's what you do. You always take the absolute of it. When you take absolute, it means you square root and you square the components. It means to take the magnitude of the vector, right? So if you got vector A, B, if you're taking the absolute, it means you're finding the magnitude of the vector. It becomes A squared plus B squared. It means magnitude of a vector. And you know, speed only has magnitude, right? Velocity has magnitude and direction.
So it can be negative. The direction can be, yeah. Okay, okay, okay.
Yeah. This here means it's in the negative 6. It means it's in the x direction and nothing up. So there's the x direction here, right? So there's 0. It means negative 6 in the x direction. We're going in that direction, negative 6. So that's your vector here, negative 6, 0. Okay. But now if you're finding the magnitude, it's actually, yeah, what's the magnitude? The magnitude is actually 6, right? Are we good?
Yeah, good stuff.
Yeah. That is speed. Yeah. hmm Yeah, that's great. Find the average speed over the given interval. Wait a minute. What's average speed? Average speed is, I think this is a theoretical question. Find the average speed. See, it's like average value of a function. C. What's average value of function 1 over b minus a integral a to b of f of x dx. But now they want average speed, right? And what's the interval that they gave us? 0 to pi, isn't? Okay. And what are we going to integrate? Average value of function, finding the average speed. Correct? So I think you need to integrate 6 dt. All right? Yeah, because that's the speed. And to find the average speed, yeah, that is the speed, which is 6. You want to find the average speed. Yes, correct. Now, so this is like your time that you are dividing it by, isn't? So your average speed will be 1 over pi. If you evaluate this, it's going to be 6t 0 to pi. So you got 1 over pi into 6. You can take out a 6 as a common factor and just say pi minus 0, right? And you can see the pi and the pi cancels out. So average speed is just still 6. Are we good?
Yeah.
That's it. Your average speed is still 6. All right, so we can now end off. We have done 3 lessons, right? And most of them were basically on parametric curves, right? Vector value function is like an extension of a parametric curve. So I hope you understood everything.